Okay, this video is going to talk about how to take all the information that we just learned in all the other videos and put it together to create an equation based off a graph. So the first thing that we need to know is, what are the zeros? Are we touching or crossing? Does that mean that the multiplicities have to be even or odd? And that's the very first place I start, is right here. The next is the name of the function is w of x, so I'm going to go put that down here, w of x equals. And then I'm going to list the zeros. There's a 0 of -3. At -3, the graph is crossing, which means the multiplicity has to be odd. The next x-intercept is -1, or the next 0 is -1, because the intercept would be -1, 0. It is touching, meaning going up and then coming back down. It's not going through, it's going down, which means that the multiplicity of that 0 has to be even. The last one is 2, which it is crossing, which means the multiplicity of that is odd. So I have all three x-intercepts, or all three zeros, and the behavior near them, which is touching or crossing, and that tells me what the multiplicity has to be. So I'm going to say I have no idea if I have a vertical stretch or some kind of reflection here. But I can tell you that this overall looks parabolic when it goes off, shoots off to infinity. So this thing had better, the whole function had better have even degree. Because in the end, not in the middle, but in the end, it looks like a parabola. So going back to our information, the only way to get a -3, 0 is to have an x plus 3 here. The smallest odd number is 1, so use that. The only way to get a -1 here is to have an x plus 1. The smallest even number is 2. The only way to get a positive 2 here is to have a factor of x minus 2, and the smallest odd number is 1. So now I have the skeleton of my function. I'm going to go see if I have an a value right here. And so if I have no a value, you have to assume it's 1, but I have to go find that by using some algebra. There is a really handy trick here. This ordered pair, 0, -3, is the y-intercept. Using that information in this function is going to tell me a lot about what's going on with this number here. And here's how that works. You've got w of x equals some a, and then x plus 3 to the 1, x plus 1 squared, and x minus 2 to the 1. Instead of writing w of x, put the y value of 3 in there. So there's, in this case, it's -3. And all these x's that are associated with a y value of -3 have to be 0. When you do that, you get -3 equals, and by the way, you don't have any x's and y's anymore. All you're looking for is a. So you've got 0 plus 3, which is 3, 0 plus 1, which is 1 squared, 0 minus 2, which is -2 to the 1 power. 3 times 1 times -2 is -6. And when you have this, you have a equals 1/2. So now you know you did have an a value, so you have to rewrite your final answer of 1/2 times x plus 3, x plus 1 squared, and x minus 2. And that is the function that matches this graph right here. Doing that last check here is, did you get an even degree to be able to deal with the going off to infinities? So this is 1, 2, 3, 4 x's. So yeah, that's an even. Take a look at that one. So you have example 7, which is exactly the same process as we did in example 6. Pause the video. Do this one on your own based on the things that we did for example 6, and then unpause the video and check your answers. So here's example 7. I'm assuming that you have paused the video and done the process, so this is not the first time you see it. So for the 0 of -2, it touched, which means this had to be an even number. 0 behavior, and then multiplicity has to be. The next one is 1. It crosses, so that has to be odd. So now you have a skeleton of f of x equals a times x plus 2. That's the only way to get a negative 2, 0. Smallest even number is 2. X minus 1. Smallest odd number is 1. That's your skeleton. You're going to use the ordered pair 0, negative 4 to inform you about whether or not you have an a value. So you've got not 0 equals, that's an x value. So nope, that's not going to work. But the y value, which is what you replace f of x with, is negative 4 equals a times 0 plus 2 squared, 0 minus 1. So that would be 0 and 0 because that's the x value that you shove in. And then you solve. You have negative 4 equals a times 2 squared times negative 1. Negative 4 equals a. 2 squared is 4 times negative 1 is negative 4. Divide both sides by negative 4 to get a by itself. And you get that a equals 1. So if I were to actually write this out, it would be f of x equals 1 times x plus 2 squared x minus 1. But we don't ever write that. We never have the 1 there. So it always appears that there's nothing there, that you didn't have an a value, but you actually did. It was just 1. We don't write 1. So that's how you take a graph and create an equation. Continuing on, before we can take an equation and make a full graph, we need to do a couple of pieces of checking. And that's with the turning point fact. This is just a fact. So as you can read, a turning point are our local maxes and mins. And the rule is that a function whose degree is n, no matter what n is, can have at maximum n minus 1 turning points because it's got to turn and go off to infinity that last one. So it doesn't have n turning points, it has n minus 1 turning points. Also, if you see a graph and it has a certain number of turning points, the degree is at most 1 above that. So let's see how this plays out by pausing the video and actually graphing some of the other, you've got some things on Desmos already, and see if that actually plays out, and then also taking a look at example 5 below. So example 5, I have 3 functions. One of them is an equation and 2 of them are graphs. The degree of this function using mental math is this x to the 1 power being multiplied by this x cubed power being multiplied by that x to the 4th. When I add all of those up, I get that the degree of this is 4, 5, 6, 7, 8. So the degree is 8. Using the turning point fact, if you have a degree 8 polynomial, you can have at most 7 turning points, which means that you can have 1 turning point, 2 turning points, 3 turning points, 4 turning points, 5 turning points, 6 turning points, 7 turning points, but you can't have 8, 9, 10, or above. A function gets to utilize however many turning points it needs, and this one can have at most 7. It can certainly have less than 7, but it can have at most 7. So looking at a graph, I have 1 turning point, 2 turning point, 3 turning point, because these are all local maxes and mins, which means the highest degree this thing can actually have is a 4th degree polynomial. And not the highest degree, let me back up on that one. So it can be a 4th degree or higher. Like this has at most, this is 4th degree or higher. So taking a look at the last one, really honing in, I have 2 turning points, which means I can have a 3rd degree polynomial or higher for my function. And these provide us with some really great checks and balances to what we're doing. Because really, this last piece of this is what we are doing for these functions. The very last piece here is steps to analyze a polynomial function. Your textbook because you've had the textbook open while you've been doing the notes, is definitely different here. It has way more steps. But I have a 4-step process. And sometimes I do these in different orders, but just to be consistent here, we're going to do step 1, step 2, step 3, and step 4. And the point is, we're going to be using all this information to take an equation and make a graph. So I'm going to throw a graph on here right now. And I'm going to, as I go through steps 1 through 3, I'm going to go ahead and put information on there. And the first step is to determine the degree of the polynomial, and then let that inform you of what the end behavior. So basically, are you going to infinity to the right, going infinity to the left, going to negative infinity to the right, or going to negative infinity, or some sort of going to opposite infinities? So that starts with the degree of the polynomial. The degree of the polynomial is the highest exponent. I'm not going to multiply this out. I'm going to say that when you're done with x plus 1 cubed, your highest degree in this point is going to be x cubed, and you're going to multiply that by x. So your degree for polynomial, that tells you that either you were this or you were that. Either you're opening up or opening down. Either at the end behavior, you're going to go shooting off to infinity, or you're going to be shooting off to negative infinity. And the only way to know which one you're in is to take a look and see, do I have a transformation that reflects you across the x-axis? No, because there's no negative sign there, so I know I'm not this. I know that in the end, as x goes to positive infinity, my y values are also just going to shoot up to the sky, and as x goes to negative infinity, my y values are going to shoot off to the sky. They're going to be positive. Said another way, as x goes right, y goes up. As x goes left, y goes up, which is what this is, right? To put that like a note to myself, on my graph, I'm like, hey, don't forget that in the end, you got to go up on both sides. Step 2 is finding x and y intercepts. All of these ordered pairs are going to be super important. To find x-intercepts, I want to remind you that they're ordered pairs where the y value is 0. So you can set your original equation equal to 0 and solve for x. That looks like 0 equals x plus 1 cubed, and then x minus 3. And then you get 0 equals x plus 1 cubed, and 0 equals x minus 3. Here's an easy one. X equals 3, so there's my first x-intercept. And this one, I need to take the cube root of both sides. The cube root of 0 is 0. X plus 1, and this one, x equals negative 1. Here's your other x-intercept. Negative 1, 0. 1, 2, 3. Boom. And a negative 1 here. All right, so I've got x-intercepts. Put a little dash line to find the y-intercept. You have to remember the y-intercept is where x equals 0. So I'm going to put f of 0 into my function and get 0 plus 1 cubed times 0 minus 3, which is 1 cubed times negative 3, which is negative 3. I'm going to plot that. 1, 2, 3. There we go. And last but not least is to talk about the multiplicities, the zeros and the multiplicities. But something that I absolutely love right now, you already know your zeros because you found the x values of the x-intercepts. So I'm going to make myself some space here by shortening up my y-axis. I'm going to do my little chart. My 0, my odd or even, right? Touch or cross based on that. So my 0 here is 3. My second 0 is negative 1. And its multiplicity on the negative 1 is odd, so it crosses. The multiplicity on the 3 is 1, so it's another odd number, and it crosses. Notice I used to have a table that had 4 columns. Now I've just kind of shrunk that to 2 or 3 columns. So that means that I cross, I'm going to put a little c, and cross. So the first thing I know is that I'm going to take a function, and it's got to cross the negative 1, come down and touch negative 3 at the y, kind of go back and cross at the x-intercept of 3, and it has to go up on both sides. You're welcome to use Desmos to see if that works. Since you're back from using Desmos, taking a look at number 9, you need to do this one on your own, and then we're going to check it in class. So that'll be something that I'll check and make sure that everyone's done. And the next piece that you need to do is go and attempt some of the homeworks, and then get a list of questions you want to ask me about section 3.1. We're going to start on and I'm really talking about like 15 minutes on 3.1, and then we have to move into 3.2. So really distilling your questions would be great. Thank you for watching the video, and I can't wait to see you in class.